So in this video I'm going to discuss code forces around 925 rated for division 3. So I will be solving first 5 problems of this problem set. So let's start with problem number A. The name of problem A is setting up camp. So in this question I will be given 3 integer number A, B and C, which represents A introverts, B extroverts and C universals. And there is a condition like a introvert would like to live one only in a tent, which means there should be at least only at most one person if there is an introvert in a tent, and there should be at least 3 people in a tent where an extrovert is, and universal doesn't matter, which means universal can be live single, can be live in pair, can be live in 3 pairs also, and there will be at most 3 people in a single tent. So I have to tell them whether it is possible such that it is possible to possible to allocate tents, or it is not possible, or I have to tell them what is the minimum number of tents possible if the configuration is possible. So let me tell you how you can solve this problem. So let's suppose there is a tent like there's a configuration like A, B and C. So first I have to find that whether it is possible to place tents or not. There is a condition. Mm, there is a condition like my total 3 people, my total extroverts, for example this is, I will let it, for example this is introverts, this is extroverts and this is universal. So for an extrovert there should be exactly 3 people in a tent. Yes. So I can, and for an introvert there should be only 1 people in a tent. Yes, this is also satisfied. So what I can do, I can simply check whether my extroverts are divisible by 3. If my extroverts are divisible by 3, which means I can place all of my extroverts together in a 3 pairs and they should be valid. But if my extroverts are not divisible by 3, which means my extroverts are divided by 3 is not equal to 0. It is modulus. So what I can do, I can simply try to borrow some of the universals, because for universal it does not matter, because universal can live with extroverts, live with introverts. It does not matter for a universal. So I can simply try to make pairs of 3 in which my all of the extroverts will be covered. So first I will check this. If my condition is satisfied, which means my some of the extroverts can live together and some of the extroverts can live together with, with universals person, with universals. So if this condition is satisfied, I can simply check yes, my answer is valid. I can form an answer. But then how I can form the answer? So that is also pretty much interesting part. So similarly, answer should be number of introverts, because because in a single tent introvert be single only. So number of introverts is a minimum condition. Yes. Okay. Now next condition. Next condition is that if my extroverts are divisible by 3, which means if my extroverts are divisible by 3, I will simply add extrovert divided by 3. Okay, yes. Then I will simply check whether the remaining number of extroverts, which cannot form a pair of 3. For example, let's suppose 2 extroverts are remaining. Simply then I will try to find that whether I can get borrow one of the universal from this and make a pair of 3. For example, if I borrow a single universal from this, then a pair of 3 is possible here, which means I can form a pair. Yes, I can form a pair. Okay, great. Then e by 3 10 for this, 1 10 for this. Then you know how many universal I have borrowed. Total number of 1 universal I have borrowed. Then the answer would be u minus number of universal I have borrowed. Then then I can divide this number into 3 parts and find the final answer. So if I show the code is also easy. First of all, I'll check whether my extroverts are divisible by 3. Then I simply add introvert in my answer, b by 3 in my answer, and simply try to divide extra universals into 3 tents, because at most 3 people can live in a tent. Okay, then what next? Then I will simply try to complete the pairs, which means whether the extra number of pairs. For example, in this case, my 2 extroverts are remaining. Then I will try to find the pair of 2 extroverts with universal and make it modulus equal to 0, modulus 3 equal to 0. If this condition is satisfied, then I can simply find the another pair. Okay, find another pair. Then the left number of extroverts, then the left number of universal will also form a pair and find the answer. Okay, so that's how you can solve the problem number A. So let's now discuss the problem number B, that is firework. So in this question, I truly say that in the contest, I haven't read the problem statement itself, but simply seen the input output and try to find the answer. So I will try to I will tell you that part only, because I itself haven't read the problem itself properly. So in this question, if my this m, which is the range of firework, which means the range of a firecracker, is smaller than both of my A and B. Okay, is smaller than both A and B. Then I will simply have to print 2. Okay, great. But if my range of firework is greater than A and B, then what I have to do, I simply find the, for example, this is my answer, then what I have to do simply, for example, this is my M, then divided by 5, which is A, plus simply that number, what I have to do, plus simply divided by number divided by 6. Okay, then simply add 2 in my answer and make a roundabout. Then this is my final answer. You can see this is my final answer which I was getting. Yes, so this is it. If my M is greater than A and B, then simply divide A by M, B by M, and add 2 in the final answer. So that's how you can solve the problem B. So let's now discuss the problem number C. It is left and right house. So it is pretty much interesting brute force problem. If you are able to understand the problem statement itself, then it's only a matter of 3 minutes in implement, or 2 minutes in implementing the final solution. So let's now discuss the problem solution. Problem statement. So in this question, let's suppose I am having some number of houses, and houses are represented by 1 0 1 0 1 0 1 0 1 1 1 0. Let's suppose there's also randomization here also. So for example, this is the array given to me. Okay, so in this case, 0 represents that this house wants to be on the left side of the road. Okay, want to on the left side of the road. If it is 1, then the house want to be on the right side of the road. Okay, so how I can make a road? For example, this is my number of houses. For example, if I try to make a road here, okay, then I will try to find what are the number of houses on the right. For example, this is the right part, then, and this is the left part. Okay, great. So now tell me, what are the number of happy houses? So simply, happy houses are those houses for which, if they are on the left and the values are 0, if they are on the left and values are 0, then these are happy houses. And also, if the values are on the right and its initial value is equal to 1, then that is also a happy house. Okay, great. So this is only the condition of happy houses. But in this question, what I have to tell them, I have to make a road in array itself. Okay, great. But there is a condition. If I want to make road here, then total number of happy houses on the left should be greater than the number of houses on the left. For example, how many houses are there on the left? 1, 2, 3, 4, 5, 6, 7, 8. So total number of 8 houses are there on my left. Okay, yes. Then tell me, then total number of happy houses should be greater than 8 by 2, which means total number of 4 and greater than 4 houses should be happy. Okay, total number of greater than 4 houses should be happy on the left. And similarly, what are the total number of houses on the right? 1, 2, 3, 4, 5, 6, 7, 8. Also 8. Which means total number of 4 houses again should be happy on my left part, on my right part. In short, what I'm trying to say, total number of at least 4 numbers should be there which are equal to 0 on the left, and there should be at least 4 number on the right which are equal to 1. Okay, yes. So it itself a pretty much brute force type problem. For example, you can simply count the total number of ones and zeros and simply start a diversity from the array itself and checking whether you are counting whether you are getting a 1 or 0, 1 or 0, 1 or 0. And similarly for each and every position, try to find whether number of zeros on the left are greater than the length of the left part itself, and also the number of ones on the right are greater than number of ones itself. So that's how you can solve the problem. But also there is a catch along with it. What is the catch? For each and every I have to find the n by 2 minus I and minimize this number. Okay, so that is also easy one. For example, let me tell you again. So if hypothetically I'm taking that, but this is also valid a road, which means, let me erase the extra part. Okay, great. So now tell me, I'm taking hypothetically. For example, this is also valid road. Here also a valid road is coming. Here also a valid road is coming, which means my this segment, for particular this road, when this is happy and this is happy. For this part, when this is happy and this is happy. Similarly for this part, when this is happy and this is happy. And similarly for the last part, when this is happy and this is happy. Okay, great. Now for each and every index, I will find one more value, that is n by 2 minus I. So let me n by 2 minus I, which is an absolute difference of this. So for each and every value, I will find the absolute. I will find this value also. And whosoever is giving me the minimum value of this part, I will print that answer. So that's how you can solve this problem. So let me show the code. The code is also easy. Similarly, what I'm doing, I'm simply making two variables, right count 1 and left right count 0. Okay, which represents, okay, which represents total number of ones in the right part of the array, total number of zeros in the right part of the array. Okay, great. Right count 0 and right count 1. Okay, similarly I'm creating answer array. I will tell you the meaning of this letter. And similarly, if my current value is 1, I will simply increase my left count 1 and decrease my right count 1. Okay, if my current value is 0, I will simply increase my left count 0 and decrease the right count 0. And if my left part is happy and right part is also happy, then I simply push back n by 2 minus I in my answer with along with the index. Okay, what is this function? You can simply write, if my left part is happy when my number of zeros is greater than the length of 0 and 1, and my right part is happy when my number of ones are greater than 1 and 0. So this is a right happy and left happy function. So if my both of the conditions are satisfying, then what I will do, I will simply push the n by 2 minus I comma index in my answer and simply sort the final answer at the end. If my then after sorting, I will get the minimum value of n by 2 minus I, that is n by 2 minus I at the zeros index, and simply print the index of that part. Okay, for example, the SSI is second here. So that's how you can solve the problem with 3 also. So let's now discuss the problem body, that is the Seraphim and the owl. So it is pretty much interesting problem. So what the problem is asking us to do. So there's a queue of n numbers, and each of number represent a person. And there's a guy who is late in the line, and he gets checked at the end of my line, which is at the n plus 1 position. Now he want to be among the top m persons in a queue. Okay, top m persons in a queue. Here's the m given to me. Now he want to be top m person in the queue. Now to get further ahead, what he can do, he can simply exchange a position with some another number. For example, in this case, my guy is like at end position. Okay, great. Then if I want to swap with three this index, so let me teach you here. So so let me take this test case. Okay, great. Okay, great. Now let's see. So initially my guy will be here at this position. Okay, yes. My guy will be at this position. Okay, now what he can do. If I want to swap position with this index, for example, he want to come at this position, then what he can do in single operation, he can simply add the th value. For example, this is my A array and this is my B array. Then the number of costs required to come to exchange value with this person is similarly the value of this eighth person. Okay, value of this eighth person, and the all the values between a and the position where he is current at. For example, currently he is at this position and he wants to come at this position. For example, the guy is at this position and he want to reach at this position. Then the cost required to come at this position is simply 9 plus number of bits between his current position and the value he want to be at. For example, the cost will be 9 plus 7 plus 1 plus 4 plus 9. So this is the cost which is required to come at this position for my current person. Okay, great. Now there's also given m to us. Okay, now what is m represent? Which means he want to be at the top m person in a queue. For example, let's suppose if this m is 2. For example, if this m is 2, then he wants to be among these two persons. Okay, then he wants to be among these two persons. So how we can find the minimum cost required to come at among the top two persons for it? So how you can solve this problem? So this is a pretty much greedy problem. So let me tell you again, it is pretty much greedy problem, not a DP one. You can also say DP also, but I would suggest it is a greedy problem only. So let me write a random test case. For example, 2, 3, 7, 9, 1, 2, 7, 8, and let's suppose 1, and here it is 10, and here it is 2, and here it is 5. My guy is at this position. Okay. Now he wants to come at this position. Now tell me what is the minimum cost. That is what I want to find. Okay, yes, that is what I want to find. Now if my person want to come at this position, then what is the cost required? the cost required is simply 2, because the position he if the position he wants to come at simply adds up the eighth value. Okay, this is the eighth value, and there is no b value between the current position and the reach position, so no b will be added, so the eighth value will be added at that. Now tell me, if he wants to come at this position, then what is the cost required? What is the how he can reach here in the minimum cost? So you will tell me, let my person will add 1 here and b would here also. So the total cost from this position to this position will be 1 plus 5. No, but this is not a minimum cost. But how? I will tell you later. I will tell you. But how? For example, if my person first travel at this position, if my person first travel at this position, that is 2, then at this position, that is 1, then what is the cost? Then cost is simply 1 plus 2, and it is also a valid operation. Then 1 plus 2 is equal to 3. Then that's how my person can come at my third index. So this is the minimum possible cost. And for each and every index, for example, if he wants to come at this index 1, then what is the minimum cost? This is simply 1 plus 2 plus 7, then add then finally 1. Then my cost will be 1 plus 7 plus 1 plus 2. Then that's how you can solve the problem and find the minimum possible answer for this solution for this problem. So that is also easy. So let me teach you in this case. For example, my person wants to come here. Okay, and he is currently at this position. Then what is the cost? Cost will be 9 plus 4 plus 1 plus 2, and the value he wants to come at would always be added eighth value, because eighth value of that pass will always be added. So my answer would be 9 plus 2 plus 1 plus 4 plus 9. So that's how you can solve this problem. If I show you the code is also easy. I have simply input my A and B array and simply try to find. I will simply try to add the minimum of A and B, A of I and B of I in my answer. And if my current index is more than I, which means among the top m numbers, then I simply add the previous number and the value of eighth value of the current index, because my eighth value will always be added if I want to be added this index. Okay, then A of I plus current and simply print the answer. So that's how you can solve. So that's how you can solve this problem easily. And okay, so that's it for it. So let me discuss the last problem. That is problem number E, binary search. So in this question, I will be given a random array, and I have to apply a binary search on this question, and I have to tell them what is the minimum number of swap possible. So that, and this is not a sorted, this is not a sorted array, and in a non-sorted array, I have to apply the binary search and try to find the minimum number of swap possible. So that in an unsorted array, if I apply the binary search, then my answer would always come. So that is not pretty much explaining in this problem. So I will simply try to show the code. So lastly, I will try. So last problem which I was able to solve this problem set is E binary search. So in this question, I have to apply binary search in an unsorted array. Okay, and I have to tell them the minimum. I have to tell them what are the possible swap which I can perform on this array. What are the possible swap which I can perform on this array, such that after applying the binary search on the unsorted array, my answer would always come. Okay. So for example, if I'm having like this array, I'm taking a random array like 1, 3, 2, 4, 5, and 6, and I'm searching for 3, and I am searching for 3 index. So my first index would be at this, and my last would be at this. The minimum would come at this position 4. Okay, yes. Is my 4 greater than 3? Yes, my 4 is greater than 3, which means I will try to find in a smaller search space. Okay, then I will the mid of both these numbers is 2. Okay, if is my 2 smaller than or greater than 3, it is smaller than 3, which means I will try to, now I will go in this part. Okay, yes, now 4. Now now my now my search page is ended. Now, so what are the possible swap which I can perform to find the answer? That is simply 2 and 3, which means at the end my final comparing is from this index. Then I will if I swap my target value with the last swap which I was on, then I will get the answer from my binary search. So that's how you can solve the last problem. If I show the code is also easy. Simply perform the normal binary search. Okay, perform the normal binary search. This is L, this is left, this is right, and left minus R greater than L, and fine. If my current element is smaller than my target, then simply increase my left part, else increase the right part, and check if my last index is equal to my x index, then simply print 0, else simply print swap one operation and swap the index of my last index and the x, and then simply write one operation is required, and the swap operation will be simply the index which you finally own, that is L, and the index of last, and the index of target. So that's how you can solve the last problem. If I repeat, simply perform the binary search as usual, and check if and check the last index where we were currently on, and see if that index is equal to my x index only, then simply print 0, which means 0% is required, else simply print one operation is required, and that operation will be x index and the last operation where you finally has been. So that's how you can solve the problem very easy also. So if you like the video, please don't forget to subscribe my channel. And sorry for the last two contests which I was not able to form the video because I was some also busy somewhere else. So now I will try to make the video on each and every contest at the end. So stay tuned for the next one, and till then stay tuned for the next one, and don't forget to subscribe my channel. So bye.